Your model aces training but fails in the real world, and that's overfitting. The number one reason machine learning models fail in production. Today, we're breaking down why it happens and the 4 techniques that stop it. Your model trains on these green points, but instead of learning the pattern, it memorizes every point, including the noise. The red curve fits perfectly, yet when new orange test data arrives, predictions are way off. That's overfitting. Low training error, high testing error. Your model memorized instead of generalized. And in production, that's catastrophic. On the left, you have underfitting, where the model is too simple, like drawing a straight line through curved data. So it misses the pattern entirely with high bias. On the right is overfitting, where the model is too complex and wiggles through every point, giving perfect training but terrible testing with high variance. The middle panel shows the sweet spot. Just right, capturing the true pattern without chasing noise. This is the bias-variance trade-off, and your goal isn't perfect training accuracy. It's finding the balance that generalizes to new data. Why does overfitting happen? Too many parameters, too little data, noisy signals, or training too long. Look at these networks. The simple one has limited capacity. The complex one has millions of parameters. More complexity equals higher risk of overfitting. Always. The solution is regularization, your shield against overfitting. It constrains training so your model learns patterns, not noise. 4 techniques. L1 Lasso penalizes absolute weights for feature selection, L2 Ridge shrinks weights smoothly, Dropout randomly disables neurons, and early stopping halts training before memorization begins. Use them alone or combine for stronger protection. Regularization adds penalties to keep weights in check. L1 drives irrelevant weights to 0 for feature selection, while L2 shrinks them smoothly to prevent dominance. Dropout randomly disables neurons, forcing the network to learn robust features instead of relying on specific paths. Finally, early stopping halts training the moment validation loss rises, preventing memorization without extra parameters. Together, they ensure your model generalizes instead of memorizing. Overfitting memorizes while underfitting misses patterns, so combat this with L1 for feature selection, L2 for weight control, Dropout for robustness, and early stopping to halt training at the right time. Combine these techniques using the simple formula. Regularized loss equals original loss plus penalty. Your model learns patterns, not noise. Thanks for watching, and follow, and subscribe.